Hey everybody, welcome back to the Pomerium live stream. I'm your host Nick Taylor, and today I'm hanging out with Glauber Costa, CEO and founder at Turso. How you doing today, Glauber?
Hey Nick, doing all right, man. Thanks for having me on once more.
Yeah. No, it's it's crazy to think that the last time we did a live stream, we've chatted in on socials and stuff, but it's been like 3 years, so crazy how
Different
time
world.
flies.
We live in a different world.
Yeah, seriously. Yeah, so yeah, speaking of different world, obviously AI is not AGI yet, but I was reading the other day, some people were saying like the models we have right now, if they saw those in 2022 or 2023, they were saying maybe it is AGI. It's pretty wild what's happening. There's good and bad, obviously, but yeah, I guess before we kind of dig into things, for folks who might not be aware of who you are, who is Glauber, the man, the myth, the legend?
Well, nice to meet y'all in the stream. I'm Glauber Costa. I've been a systems level software engineer and adjacencies for my whole life. I always did like business as well and company building and delivering real value, yada yada yada, which is the intersection of that was me becoming a founder. But in the first 10 years of my career, I was in the Linux kernel, initially at Red Hat, but some other companies as well. And after that, I joined a company that became a database company. They were not initially, but then became a database company called Scylla. That's
Yeah.
how I got acquainted with the world of databases and spent another 8 years there. And then later, after a short stint at Datadog, founded Turso.
Oh, I didn't realize you're at Datadog. Okay.
The thing is that again, I had two big blocks in my career that lasted almost 10 years, and that's how I like to do things. I'm one of those people that believe that I was never too much into like job hopping or I optimize for different things. Like people doing that optimize for one thing, and guess what? I mean, they get the thing that they optimize for.
Yeah.
But for me, it was mostly about understanding things deeply, getting to be a part of a community. And those things are very hard to do if you're doing like 3 months, 4 months, 5 months here and there. You really need time. It's the kind of thing like a marriage, like raising kids. You need time to see those things bloom. So when you look at my career, like it was really like one decade here, another decade there, really trying to see this to fruition. But then when I was ready for the next step, my next step would have been into a very crazy world of COVID. I mean, I left Scylla in 2020, and 2020 was a very interesting year. And then I
Yeah.
decided to join Datadog. It was great for me in a lot of aspects, but also fairly clearly, I'm more of a build from scratch kind of person. And after
Yeah.
1 year there, like the world was good or bad, stable. Because good is fine, bad is fine too. The thing that is hard to deal with is change, right? So in 2020, nobody
Yeah.
knew where this was going. In 2021, it was already clear how things were. So at that point, I just started the company with my co-founder Pekka.
Okay. Yeah. And it's kind of interesting because we've been like there's been a lot of Discord, like GitHub's been down a lot recently, and there's been people talking about alternatives to GitHub. And I find it funny because you were a systems programmer, you worked on the Linux kernel, and I'm assuming you were emailing patches still back
Oh
then.
yes, oh yeah.
So it's just kind of funny. It's like, yeah, it's solved. We fixed it. You just send the email.
Well, not really. I mean, I have a very set of strong opinions about GitHub, and a lot of people are focusing. One of the questions that people have about GitHub is, it is so terrible. Why don't people leave? And we're on GitHub, and we don't leave. And when you go look at why is that, it truly is the way people use GitHub today, and including us. It truly isn't about merging code and storing the code. So a lot of the discussion about that usually go around, hey, why do we even need a centralized service for this. It's just source code, but I think source code is a tiny sliver of the reason people use GitHub for. It's mostly what happened. If you go look at GitHub today, it's mostly around CI/CD and what happens in the deployments, and so GitHub is down and we can't deploy it to our platform, which is a big issue. But the reason we can't deploy it to our platform is not because the source code is on GitHub. I mean, the source code could be anywhere.
Yeah.
It's because there are a series of automations built from like what happens once the source code becomes official, what happens from there on. So the email flow doesn't solve that. You right? So just so it's but yeah, it's we started when I started in the Linux kernel, Git did not exist. So I saw Git, and obviously throughout the years, it's evolution.
Yeah. What was the source in originally? Because like my first encounter with source code was SVN.
Yeah. So in the Linux kernel, the source code truly wasn't anywhere. In a sense, like it was just like patches in the mailing list, and Linus would pick them, and so that at some point there was a source control tool called Bitkeeper that was used by some of the maintainers, but it was not mandatory. Linus used it, but I never used it, and it was like a completely optional thing. And there were a lot of like bespoke tools. One of the ones that I used a lot was called Quilt, which was created by a maintainer of the kernel at the time. And most of those tools were like a version of Linux had a tar GZ release, and then you would have a collection of patches on top. And most of those tools were tools to manage the order in which you apply the patches and what are the patches, and just a list of files with the diffs. So that Bitkeeper was, I suppose, the inspiration for Git. Bitkeeper had a lot of the same characteristics that Git had. Massively distributed. I mean, it wasn't mandatory. I mean, just the maintainer had to use it. The people sending the code did not. And then one of the things that happened is this was a very famous thing, a very high-profile event in the Linux community. Bitkeeper was a proprietary tool, so a lot of people do not use it because of that, including myself. And people at the time sometimes had a resistance towards proprietary tools. And in the agreement that Bitkeeper had with the Linux kernel, the tool could not be reverse engineered. And then one of the people from Linux reverse engineered, despite the licenses saying we couldn't. But again, it's one of those things like when you read about the Celts and the Romans and whatnot. Like one of the things that made it very hard to make any kind of trade agreements with the Celts is that they didn't have a centralized structure. So you reach an agreement with one chieftain. Like, what does that mean? The next guy will not respect you. He doesn't care. And it was a little bit like that because I mean there was this. You can't really sign a document with the Linux community. You do that with certain individuals in the community. Then somebody reverse engineered the protocol to try to make his own client. Then the guy from the Beekeeper community or vendor revoked the licenses, and then Linux was left without a source control system, like overnight. And then famously, Linus Torvalds disappeared for 3 weeks and emerged back with Git. That's the story of how he came to be.
Oh, okay, cool. Yeah, it's. I think it's always nice to get a bit of history on some of the tools you use, And this is a perfect segue to talking about open source. Obviously, open source has changed over the years. It's definitely changing with AI. Like even Pomerium, where I work, we're an open core Identiware proxy, and we're going to stay open source. And obviously, AI is in terms of contributions, we have AI disclosures and stuff now. Like we still encourage people. But it's just don't throw up an AI slot PR, basically, is the TLDR. But I'm asking this because we were talking briefly just before the live stream. So Turso, I guess we could give an intro, like what is Turso? I think from the high level, like I use it on my my own website for basically stream guests and a few other things, and it's SQLite like or very
Yeah.
close to it. And I guess yeah, first question about the why. We asked this a few years ago when we had our live stream, but just kind of why it came to be, and then like why are you still open source and your thoughts on open source?
Yeah, so Turso is a full re-implementation of SQLite. I mean, sometimes the word rewrite is used. It is a word that I don't have any qualms with that, by the way. I use it sometimes depending on the context. The problem with a rewrite is that people expect that whatever was there before maps one to whatever is there later. So, and this would describe things, for example, the TypeScript rewrite in Go and the bun rewrite in Rust is like, hey, this
Yeah.
is almost like line by line. Like I had this and I'm writing it again.
Yeah.
And again, I actually, as I said, I think the word rewrite applies to what we're doing too, but what we're doing is not that. So if you want to differentiate from this, then is a re-implementation or a rebuild of or reimagining whatever word that you want to use. And the
Okay.
difference is like, look, we Turso from the outside, you will especially depending on what you're doing, you will not be able to tell the difference between that and SQLite, right?
Yeah.
There's always a long tail of things that are not done yet, and if you happen to do them, you will find very quickly that it's not the same thing.
Yeah.
But you know, if you stay within the lanes of what is done, you shouldn't be able to tell the difference at first. And but the inside is completely different, and that is and I think that is the main difference. So you can think of it like a a database that is compatible with SQLite, and what we give up with that is that we do let SQLite determine a little bit of our boundaries, which is
Yeah.
right, which is why people don't do this more often, and I think it's a mistake. That's why we do things the way we do, and it's just because once you're starting something new, you want to have the blank canvas. You want to go like, hey, I want to do, and if you're doing like a re-implementation, a compatible implementation, you kind of have to abide by the boundaries set by that project. But I think you gain more than you lose by doing this. So again, fully, it's from scratch. There's no original C code in the C code of SQLite doesn't find its way to Turso, and everything is done like that. And the reason we wanted to do this is that we believe that SQLite is a tremendously good database. It's a database that found its way through most of our industry in a very viral way. But we believe that, especially, and we have this belief again before. I'm going to use this term now, like the age of AI, which is a little bit of a,
Yeah.
make of it what you will, but it is true. We have this belief before AI, but with AI even more, right? Because SQLite really is something that we're seeing all the time in agents and applications generated by agents and simple applications. You end up with a lot of SQLite, but SQLite is kind of dated in many ways. So I talked a lot. I'm going to give you a example, which I think drives home the point.
Yeah.
SQLite. And this is not the only thing that we deviated from SQLite to do, but this is the thing that we talk about the most because it is the thing that people complain the most. So SQLite is a single writer database. And what that means is that you can only write you can only have one writer thread at a time. So and some people say that SQLite is a multi-user because of that, which I think describing things it's always hard, because different people understand different things. But if you have two users connecting to the database and one of them is going to fail, now if they're just reading, they won't. But if they're doing like a complex transaction in which you read the balance, decide on something, and then write a new balance or move a user from here to there, then one of those will fail. And the impression that everybody has is that SQLite just doesn't support multi-users. So you will start on SQLite, but as your project scales, as you start getting more users. So think about a SaaS application. when you
Yeah.
have 10 users, it's fine. When you have 10,000 users, eventually they're going to be trying to do something at the same time with the database, and that will fail. Again, this is the nature of SQLite. It works well when you have a very simple application that controls the whole thing. But more and more, and especially with agents, people are pushing SQLite to other places, and you want SQLite to be the main database for your application. And then that
Yeah.
restriction is no longer fine. And one of the things that Turso does, the chief thing that Turso does, is that we lift this limitation. You can have multi-writers with SQLite, you can have multi-users. That plus other things as well, right? So you just
Okay.
you just add, but to do this, it is something that is very hard to do by just patching what already exists. A
Yeah.
reimagining of the architecture suits it better. And then there's the fact that even if we could patch it, which technically we are capable of, SQLite doesn't accept external contributions. They don't have a developer community. SQLite has a very strong user community, but there's no developer community around it. I've heard that there are ways to get your contribution accepted to SQLite, so I'm just going to accept that to be the case, that there are exceptions, but exceptions are no exceptions. There's no community of developers with an established process on how do you come and contribute to this. So we just rewrote it from scratch, and that's what Turso is. Now, there's also a cloud service, which is probably what you had in mind when you're saying that but the cloud service is the easy part. The cloud service is like get there and deploy it on the cloud, right?
Yeah, and I got to say it's pretty easy to provision databases on the cloud, and they spin up quickly. And I think there's even a pretty generous free tier, like, you know. But yeah, I guess one question I had about the writers there, like in SQLite, could you always do concurrent writes? It's just it might be slower if you only have the one writer.
SQLite just doesn't do that. It's just
okay, so it's always sequential.
Yeah.
Okay. So that's okay. I wasn't sure if you just meant you added more writers so you could do more concurrency.
No, it's an architectural pattern. Like every time you're going to write to the database, there's a big lock that you take, and with that, you know, there's a single writer. Now, there are many other things that we have done as well. SQLite is a synchronous process. Turso has an asynchronous design, and we can go into what that means. I mean, SQLite has very loose typing. We support that because, you know, we want to be compatible, but we offer stronger typing. So there are more changes, and I think the way to describe it is that, hey, like this is a way for you to do better, keep the shape of SQLite, but let's try to do it better. But the thing that most people trip over is the concurrent writes.
Okay. Yeah. So I guess to kind of sum up what you were saying, like, I think if you need SQLite for something, you can still use what SQLite does in Turso, but you get more bang for your buck in terms of stuff like the, you know, the multi-writer and stuff.
And it's fully compatible. Like we treat SQLite users as potential Turso users. When somebody made the choice of not use SQLite, we don't feel bummed and say, hey, they got like the quote unquote competitor. That's not what it is. Right. Once you get Postgres, you go a little bit into a different direction. Although one of the things we plan to do is add a Postgres dialect support to Turso, which is a very interesting initiative that we started recently. But we still mostly, again, a SQLite shop, and we're going to be a SQLite shop for the foreseeable future. So putting the Postgres thing in the back burner, which I'm happy to go into the details later if you're interested. Once you pick SQLite, for us, you're one of us. I mean, you're part of the game here. Like the drivers are all compatible. So the idea, the file format is the same. The idea is that you should just change a line of code, and at that point you're using Turso.
Yeah, and I'll just point this out because like I did not realize all the places that SQLite exists. So like I'm sure you know, obviously, because you're deep in the space. But like for like folks that might not be aware. Your phone 100% uses SQLite somewhere in there for various things. I have an e-reader. I've got a Kobo e-reader. I discovered that it uses SQLite for the database when it rebuilds the index for what I'm reading and stuff. I discovered that just by, I was trying to add it. The Kobos are nice because you can add external documents. It's not like a Kindle where you're locked in, but, you know, and just I don't know, probably IoT. There's just so many places because I guess one thing that's nice about
Oh,
Turso and like
there's more. There's probably some usages that you haven't found out yet, because those are pretty niche. But
yeah,
SQLite is actually used as a file format by many applications,
okay,
and SQLite has native support for that. So every file in your Unix system has a magic number, right?
yeah,
That identifies that as SQLite, and the SQLite file format allows you to specify your own, and then you flip a bit saying that this is not really SQLite, this is what it is. And again, the reason for that is that you can just pack a lot of information into a file, and then you open, I think Adobe uses that for a lot of their products. Like if you open
okay,
a file, like not a PDF, but if you open a specific file for internally, it's all SQLite. And then you just, and the advantage of that is that you don't have to write a parser, you don't have to write none of that. I mean, it's just
okay,
pure
yeah,
SQL queries when you're extracting information from your file format. And once more, if you're making changes and writing to the file, you just write back to SQLite. So it's
okay.
truly used everywhere.
Yeah, that's pretty wild. Yeah, I'll be honest. I'm probably not using all the power at Turso right now. I'm using it like a traditional database, but I basically use it to store the guests I have on the live stream here, and I pull that data in at build time in my site. I'm just running an Astro site, but there's I'm not, because like this is like maybe a year and a half ago. Is there still an embeddings in Turso, or is that
Yeah,
something that
one of the things that we add to on top of SQLite is vector search. So
okay,
you can store your embeddings, you can do your search, you can do all of that, and it all sits in a file, right? So again, it's not something that will compete with the big vector databases. It's not
yeah,
our idea. It's like, hey, I have this amount of data here on my personal site, as you said, and you want to add some level of semantic search to that.
yeah,
The embeddings are right there, right?
yeah, that's on my to do right now. I'm using a static thing that generates indexes, but I want kind of more like real time, so definitely going to be looking into that. But I guess this is a before we dig into more about Turso, I'm in general, like I'm curious, like obviously there's like databases that are considered like large. They'll say it's for production, but Turso is obviously for production too. But like you're saying, like Postgres, MySQL, and these are typically considered like can store huge amounts of data. I'm curious, like obviously SQLite and Turso are I don't want to put words in your mouth, but it's not that they're meant for smaller applications. They obviously have different use cases.
Yeah, we have an advantage when it comes to smaller applications, right? Just because you mentioned, like, we have a very generous free tier, the databases come online very fast. And the reason
Yeah,
for that is that once we deploy the Turso database on the cloud, we don't need to deploy a full server. There is some level of multi-tenancy happening there. So
yeah,
there's a lot of ways in which this is a saner application. It provides a competitive advantage when you are deploying smaller things.
yeah,
Now, can it go big? Yes, right. So just if you're talking about the local database itself, there SQLite supports many terabytes of data, like a Turso as well. You can do that. Our cloud service is not really up. The trade-off and the design decisions that we make kind of assume that your database is going to be in the double-digit gigabytes at most,
okay,
and not going to cross into the 100 gigabytes. But look, when people talk about big databases, most of the time the word "big" already is evoking like a gigabyte is big. A gigabyte for us is nothing. You
yeah,
can still get there when you get to 10 gigabytes. And there's nothing special about 10. It's just like there's one more digit there, so you cross into a new level. There's a new order of magnitude. So at
yeah,
10 gigabytes, you should monitor and see if things are still working okay, right? But at 100 gigabytes and plus, I will discourage you from being on the Turso Cloud. Now you can still use the local database, and at that point you make your own choices. But our cloud service is optimized for that range from
yeah,
kilobytes, and that's something like if you go with a different solution, which is Postgres based, it's very uneconomical to have a lot of like 10 kilobyte databases. And
Hmm.
Turso will allow you to do this, right? So this is the domain in which we truly win. The smaller the databases, the biggest the comparative win between Turso and the other options. And agents have a lot of use cases that are like that, because now you have a. I used to say that it used to be the case that every software developer had a side project. No, I never actually had. My side project when I was in university was the Linux kernel. And then I went all in on that, and so I never really truly had side projects, because it was always like I'm going to go all in on my. Also, uh, unfair comparison, because I always work on the cool open source stuff. But people who have like normal jobs, well, they all have side projects. Today, I think a lot of people have 10 side projects this week, right?
Hmm.
So, and you want to keep them separated, you want to keep them isolated. Turso will give you, the Turso Cloud, as we call it, will give you unlimited databases, and each of those databases, they can be fairly small, because not all of your side projects will take off, but you want to keep them
Hmm.
around, right? So that is the problem that we solve very well. Your databases, they never go to sleep, they're always online, all that cool stuff. And they can be pretty small, and you don't pay extra for that, right?
Yeah. No, that's cool. And like, I'm glad you're talking about like, you know how like sometimes somebody will be salesy and say like, yeah, our database does everything. I'm not pointing a finger at literally anybody. It's just, it's, oh yeah, it can do that. It can do that. And like,
Well,
I like
but the
how,
reason people say that is that it kind of can. Just
yeah, yeah,
no, it might not be the best tool for the job, but you want to. And in a sense, I mean, I'm just more of an engineering minded person, so I can't help it. But that's what I'm trying to do here. I'm just telling people that, can you use a 100 gigabyte database on Turso? Probably yes, but we
yeah,
don't. I can't say that without. I think my engineering background will not let me say this without the caveat that we have not built the service to support the. You using something that was not designed for that. You might work, and you might have
yeah,
your reasons to do it, but we focus a lot on smaller databases.
yeah. And I think like you were saying to your point about agents, it seems like a perfect storm for you, like
Yeah,
people are just spinning up. Like I have like an open claw that I run in my home lab, and like currently I have it set up with like I'm using Toby Lutke's QMD, which I think uses SQLite.
yeah, that's right. Yeah.
But like obviously like I could throw in Turso there as like vector database search for like memory probably. um, and just in general, like you said, probably most people aren't going to have massive applications. People always joke about, yeah, how's your app with 0 users, kind of, like that kind of ties into the side projects a bit. But like even stuff that might blow up,
Turso,
you can
yeah, Turso is going to take it very far, because the
yeah,
thing is, if not all the way, because the thing is that, as I said, when people have this idea of like, can my data, and this is why I bring the numbers in, can my database get big? You start asking what they mean by big. It's usually a couple of gigabytes,
yeah,
and we handled that just fine, right? So just the stuff that we had trouble with is going to be the stuff where you would need like a massive sharded database, and you get
yeah,
into the terabytes of data, or like your cursor, and you're doing all like you go look at what turbo puffer does, and like millions and millions and millions of actors. Like, that's out of what we do. But
yeah,
for your app that doesn't have these requirements, Turso can probably take you all the way, however big your app gets.
yeah,
If you then become Uber, like Airbnb, that kind of scale, all of those companies at some point talk about a database migration, like the solution that you end up with, whatever. Even if you started with Postgres, you're going to have to end up in some form of sharded Postgres, and so you're going to have to change. If you hit that level of scale, you're going to have to change your stack anyway.
yeah,
Turso will take you all the way before that, right?
yeah. And I do want to talk a bit about the rewrite in a bit, but one thing I'm curious about is like in terms of agents, like what do you
The
see
right
like?
is why we can confidently say we can take you all the way up there, for example, because the problem with SQLite was always this,
Yeah,
that you start hitting issues like the lack of concurrent writes and other and there, there are others, but I'm using this as the main example. Way before you get to that scale, like, so the database, SQLite as a database could always support like terabyte-sized databases, and if you're reading a lot from those databases, it's fine. And if you have a process, like if you have an ingestion process where you know that the data is coming from a single writer, is also fine. But in practice, that's not what we see. In practice, we have CRUD systems in which you're trying to talk directly to the database. So gigabytes would not be the limit. Gigabytes was never the limiting factor for SQLite. The limiting factor has been the amount of concurrent users, because the amount of concurrent users just start generating scenarios in which SQLite wouldn't be able. So by rewriting SQLite, we lift that limitation. The gigabyte limitation was not there to begin with, so we can take you pretty far. But to do that, we had to go and rewrite it. That's essentially the reason why this had to happen.
Yeah, and I guess we can touch on it. I'll get back to my question about the agents in a sec. So you rewrote it in Rust. Rust is obviously strongly typed. It's really good with. I've done a bit of Rust. I will definitely not say I'm a Rust expert, but there's the borrow checker. Like it sets you up to not be unsuccessful, basically.
Yeah.
And from what I've seen in the little bit I've done, amazing errors, and like literally tells you what to do.
You're obviously good with Rust the same way I'm good with TypeScript. I mean, I never touched TypeScript before, and I was a complete non-entity with anything front-end related. But I've been maintaining our dashboard, and I'm contributing to our dashboard, and a user reports a bug, I just go and fix it myself. And the reason for that is that your brain just got turbocharged by agents, right? So
for sure.
As long as you understand you can take it pretty far. So it's the hard part, the stuff that I struggle with when contributing to our dashboard is understanding the concepts from the front end world, not the TypeScript. Right, as signals and then use effect, and there's a bunch of stuff that I don't even know what that is. I mean, those for me are just a word salad that I pick up here and there. And I suspect that if you come and try to contribute to Turso without having a database background, you will find a similar barrier. So you will be able to fix a simple bug that happened in the parser that is very localized, and like, hey, I hit this bug, and there's a lot that you can do that you would not have otherwise been able to do. Because Rust is not the bottleneck anymore. Rust like Neo Kung Fu, right? Just that's downloaded to your chip. The stuff that's going to get trickier is when you start needing like database concepts to understand what's going on, and the B tree and the indexes and the inverted indexes and all of those things.
Yeah, no, for sure. And I guess in terms of the rewrite, I'm assuming you did similar to what like TypeScript or Bun did. Like there was a very robust set of tests, like SQLite.
Our path was very different. Our path was very different.
Cool. Yes. I want to hear about this then, because that's what I assumed.
And it's an interesting assumption, but it can't work for two reasons. First of all, so SQLite, people are always talking about the reliability of SQLite. SQLite is one of the most reliable piece of software on earth. And it has a legendary test suite called TH3. And this test suite achieves 100% branch coverage. It has famously, I suppose, don't quote me on the number, I might be mistaken, but I think maybe 5 times more lines of code than SQLite itself. It's a really robust test suite, but it is proprietary. So we actually cannot use it.
I thought it was open source available. Okay.
It's not. And it seems also to be, again, I don't know, I haven't seen the code, but it also seems very tied to the SQLite architecture, and we wanted to follow different architecture. On top of that, we would not have been able to use the legendary SQLite test suite anyway. And on top of that, you have tests, right? You have like unit tests and you have things like that, but they're kind of useless when you're starting a project from scratch, because they all fail anyway, right? And they're more useful. We actually are in the process of running the SQLite unit tests now, right? Now, before our 1.0, which hopefully we consider Turso production grade. On the cloud is in early preview, which says more about the interaction between the cloud and Turso than the state of the project. But we plan to release our 1.0 later this year. And for the 1.0, we want the tests, the unit tests to pass. But in the beginning, they're kind of useless. And again, they're kind of useless because you have nothing to lean against. They're useful in situations like TypeScript and Bun, because again, you're translating one to one, right? And the first version of Turso, was essentially you could not. And the first version, what I mean by that is like the first thing that we published on GitHub and invited people in. And today I think we have close to 300 contributors to the Turso database on the open source. It's a very healthy open source project, but we could not write to the database. It was just a select engine, and you could not do any filters. All you could do is a select star from a table. That's it. That's all we could do, right? So there's not a lot to no joins, no nothing, no complex queries. So the unit tests are not useful. However, this is a very important point, because we know that the reason people love SQLite is just like how incredibly reliable and tested it is. And we knew that even without using their test suite, we had to have the same level of reliability, if not more. So the way we wrote Turso is that, again, from the beginning, we have something called the deterministic simulator, which is a testing technique that allows you to explore the space of possibilities for inputs and outputs, and then match against properties of the system. If the system fails, you have a deterministic reproducer that you can then step by step and makes fixing things a lot easier. We use formal methods in Turso. We use a variety of testing techniques to find those issues. In fact, our testing methodology had found bugs in SQLite many times. So we just took a different path. And I think we took this path because there is a lot more research and tools available today from the reliability community, which is a community we've been very involved with for a long time, that were just not available 20 years ago, right? Deterministic simulation testing being the greatest example. We do fuzzing, we do Oracle testing, differential testing. Almost somebody was joking about it on X the other day, saying, "Hey, do you use this testing technique?" And then the Turso folks says yes before we even hear what the technique is, right? So if it is something about high reliability, we're probably using it. So we keep a very high bar. And as I said, our methodology had found bugs in SQLite itself many times. And then what we do at this point is, of course, we report those bugs, and we want to be open and transparent about it.
No, that's cool, man. Yeah, no, and that's so like wrong assumption by me, but I hadn't heard about what was that test, deterministic testing?
Deterministic simulation testing. So deterministic simulation testing, you will not write when you write unit tests. What you're doing is that you're giving the system an input and codifying what are the outputs. When you do so, right? So you write one, and you have a table with those elements, and then you do this query, and then the result is the aggregation, and it has to be the number 3 as an integer. If you have the number 3 as a float, or if you have the number 4, those are errors, and your unit test will fail. But again, you have to specify the inputs and the outputs, and not to mention in any real system, the bug can happen only sometimes. It can happen maybe when you got your process context switched by the operating system, and then you skipped a column and you run the test again. It's going to say 3 instead of 4, right? Something like that. And when you do deterministic simulation testing, first of all the I/O that Turso does, everything that could be non-deterministic, is not done by calling the operating system. Is done by calling a abstraction layer that we have. So when you're running Turso normally, you're going to pass that through the operating system. But when you're running Turso in the simulator, you're not getting those values from the operating system. You're getting those values from the deterministic simulation tester,
Oh, okay,
right?
okay.
So whether or not the thread's going to be scheduled depends on the decision. If you get a random number anywhere, you're not getting truly a random number. The deterministic simulation tester is giving you that number. When you're doing I/O, again, any kind of I/O you're not going to go through the operating system directly. You're going to pass through the Turso DST, and then the testing will randomly create inputs, and right, so you're not going to check this output is what I expect from this input. You're going to just generally, and truly is like the more it runs, the more it finds. Like you come up with all crazy inputs that they can find, and you're going to verify that particular properties of the system held. And what are examples of properties? Examples of properties, the simplest one to understand is that the database has an integrity check, right? So, so every day Postgres has it as well. So if the database gets corrupted, the integrity check will fail. So once you run however many combinations of inputs and outputs you have, you run this integrity check, and if it fails, then the property was violated. Other properties that are easier to understand in a database, if you write a value, you have to read the same value back, or the ACID properties. Like if you have a crash in the middle, you cannot ever see a transaction going back. So what you do is that you encode these properties, and then you just let your system generate all the inputs. It doesn't really matter what the outputs are, so long as the properties hold. And then sometimes they do not hold. And then you're going to go. So for example, a lot of bugs in databases happen if you fail to sync data to disk, or if you wrote things in a different order, or if your writes were reordered by the operating system. So the deterministic simulation testing will catch all of those things, because you're creating those inputs, and you just and the I/O is fake. But again, once it fails, you're going to be able to reproduce exactly what happens step by step, because nothing was really non-deterministic in that run, right? So that we've been doing this from day one, and this is one of the tricks that we have in our book. And once more, we started with that, but now our testing methodology is yes. If it is testing related, we probably do. We do formal methods, which is we wrote a blog post the other day, the final boss of reliability. Formal methods was traditionally being something very, very hard to do. So the cost benefit of doing was not necessarily there. But with agents, it's one of those things that it's a lot easier, because you can just get the agent to write an entire spec, and so we've been doing this as well. And we have used many kinds of formal method validations as well. So just we test Turso to an extreme.
Yeah, and I guess and like any kind of test suite. So it sounds like the what is the
I just found the tweet that and the tweet was like somebody saying, which testing methodologies do you use? Turso. Okay. Yes.
Yeah, and I guess like so it's like obviously a very robust test harness, and just like tests in general, you just keep improving. Like you said, you find that bug that happened in an actual system, you get the DST to simulate that, and then it's in there forever. And
we actually had a something on a website that if anybody could find, and our plan was to increase the scope and size of the prize, but in the early days of Turso, when Turso was still like in the beginning, we were paying people $1,000 if they found the data corruption bug, with the companion simulator description of why the simulator didn't catch that. Because again, the simulator is software, is not perfect, right? So our goal is like, we know there are very few bugs here, but the ones that are here, we want to find them, and we want to understand why the simulator didn't catch them. One of them, for example, is that there was a particular kind of index that we were never really generating. And another one that was super fun was a bug that only happened in databases that were larger than a gigabyte. And our databases never got this big because our testing would crash them before that. So So we learned that,
Okay.
hey, no, we actually need to, some runs need to run for longer to get bigger data size. So those are examples of of our bug bounty program. So we would pay people again $1,000, and you had to show us what the bug was, and you had to show us where and how the simulator failed to catch it. And then the beautiful thing about it is that you never, when you're fixing the simulator, you're never really fixing one bug. You're eliminating an entire class of bugs, right? Because it's just like, hey, this bug happened because the simulator wasn't touching this part of the
Yeah.
space. Now it is. Here's 15 new bugs for you. And then you fix them all. And now you know you're robust in that area. And this was one of the victims of the age of AI because we had to cancel that program, very unfortunately. And the reason we
Okay.
had to cancel that program is that once you give the bots a financial incentive to do something, I'm sorry, pardon my French, you're effed, right? And we
Yeah.
were buried on a flurry of submissions that were by and large complete nonsense. And then we had to spend a lot of time just trying to understand, hey, is this real? Is this not real? And then we decided to cancel the program. But we had a couple of payouts before agents in which people were coming in, and it was very hard to find, but some people did find areas in which the simulator had to be expanded, and then it was, and then a whole class of bugs go away.
Yeah. No, I mean, and like, I don't know, as a startup, people might say $1,000, for a bunch of people that might add up to a lot. But honestly, like $1,000 compared to somebody getting a production bug, you know what I
Oh,
mean?
we would
Like,
our my by the way, go complain with the agents, man, because our goal was to eventually get close to $100,000 so
yeah.
in a prize, right? And it would have been around now, which Turso is going like 1.0, and again,
Mhm.
our 1.0 needs to be the milestone in which this thing is freaking perfect. So the goal is that we would start increasing little by little. But it was already hard to deal with the flurry of agents submitting slop nonsense by offering
Yeah.
$1,000. Imagine what would have happened with $100,000 prize. I mean, I, we could do this, but then you'd have to set up the system in a different way. We wouldn't be able to just take like random submissions
Yeah.
on GitHub. It's just impossible.
Oh yeah, it'd be unmanageable because like
Unmanageable,
literally anybody
unmanageable.
would just say, "Hey, ChatGPT, hey Claude, just
Yeah,
fix or find an issue." And yeah, I know not a similar project, but a pretty mature project. Curl had to stop their bug
yeah.
bounty program. He was mentioning it in the GitHub stars channel. It was just like not manageable, and people were just you know like we haven't really touched on this, but AI is gives you superpowers, but at the end of the day, it's really just a tool, and how you wield any tool, right, is like you get what you put into it, and like so
Yeah.
just people just throwing stuff against the
A,
wall,
a lot
like
of, a lot of projects, they have that stance that they don't accept AI contributions, right? Our stance was all, it's not that, but I was always joking, perhaps we should have you should disclose your use of AI, and if you're not using AI, I'm not going to accept your contribution, because again,
yeah,
why
yeah,
wouldn't you? I mean, and I have this I've been heavily AI pilled for around 9 months now. So most people cross the threshold around like January this year, when the models became like truly good. Uh,
hmm
Even before that, I would say like September, August last year, my thinking was like, why wouldn't you use this? I mean, this is amazing.
yeah,
So like we probably should ban people who are not using AI at this point.
yeah,
But we we try to be sensible about it, and our policy is, if all you're doing is describing an issue to Claude and sending us the result, we could have done that.
yeah,
So, so,
exactly, yeah, yeah,
so you need to you need to add value to the process. And if we notice that that's all you're doing, then we won't look at you anymore. But
yeah.
the bug bounty was just bad because it had a financial incentive tied to it.
Yeah, totally, totally. But yeah, like I use AI every day, and it's like there's certain things like I can obviously still write code, but most of the time I don't need to, because it's tedious syntax. It's more like, well, I don't know. My litmus test is always like, okay, does this thing actually work? Like, does it do what I actually tasked it to do? That's like just the table stakes. If that's good, then I start digging into the code, or like, why did you do it this way, or like, these aren't the patterns we usually
Yeah.
use, etc. And like, I'm not like full like Ralph Loop or like graph all that yet. I'm
Yeah.
still like
I
very
think
much.
it is not possible. And again, things may change. I'm skeptical on that front. I've always been, by the way. My stance on AI hasn't changed much in the past 9 months.
Yeah,
But I don't think we're at the point in which you can write a database like that. Now you can
yeah,
write some kinds of systems like that, but they're all fairly. I talked about it in a different podcast that I was at last week, but a lot of software is just encoding of business logic, right?
hmm,
There's a very large portion of what software is. There's very little more than I have this business problem that is describable by this business logic, and I need to encode this into the computer so that gets done. And this is very AI friendly. Like so,
yeah,
this kind of for if that is what and a lot of the like the CRUD applications fit into this. They're also not very novel. Build me a restaurant system. There are probably 1,000 restaurant management systems in the training set of the AI itself,
yeah,
and even when you need to customize, the customization that you need to make is it's essentially I have a different business logic. So this is the domain of AI, and I think it became very clear to me early on that this was going to be the thing that AI takes away. But writing complex systems, I don't think writing complex systems have a lot more than just business logic, and
yeah,
and I don't think AI is at the point in which or perhaps I might be wrong with that. Who knows? But I don't think it will ever be. The one thing that surprised me about the AI, the AI revolution, is at first I was it's like those things that we've been talking about aliens forever, and then now the U.S.
hmm,
government is saying that we have proof that there are aliens, and everybody's like, I don't care. It's something similar. Like people in our field talk about the Turing test for decades, because the day we crossed the Turing test, and then 9 months ago, it seemed to me that we kind of broke the Turing test. Like the AI could pretend to be a human and he wouldn't be able to tell the difference. And it was a
yeah,
little bit flabbergasting to me that nobody seemed to care about it. I mean, people didn't make a big deal about the fact that a machine finally passed the Turing test. But then give it a couple of months, and my stance changed that I don't actually think we passed the Turing test yet. No, I don't think any AI actually passed the Turing test, because the Turing test also needs to allow for time for you to keep asking the questions. And it's not specified how much time. And if all
hmm,
you have is like 10 minutes with that AI for the first time, absolutely is going to blow your mind away. But as a society, we kind of learn to tell Claude apart from a human. Like it's all the EM
yeah.
dashes and let's be honest here and load bearing
Load
and
bearing, yeah, load
and,
bearing.
and all that stuff. So I mean, even the Turing test that I think was like, oh my God, we passed that, and nobody seems to care. My revised position is that no AI has yet passed the Turing test because of this. Because
Yeah,
put the AI out, let X as a whole deal with that for perhaps 2 weeks, and we'll know.
yeah, yeah. It is funny though, because like I have like I use like my OpenClaw for certain things. I use it mainly for cron jobs, honestly, just doing research. Um, Not like stuff people usually talk about, like, oh, I get it to send me emails and stuff. Like, I don't have enough emails to even warrant that. But like, even though I know I'm chatting with an agent, because once you start, like if you're in that chat flow, it starts to feel like you are talking to somebody, even though I consciously know I'm not. But like I'll like, I don't know, maybe it's Canadian stuff too. I'm like, hey, thanks, man, or can you fix that, please? Like
Yeah.
I literally start. Well, I not recently. I've been doing
Well,
this
well,
for a
me
while.
too. But the thing is that, as I said, like you start recognizing the patterns of writing that the
Yeah,
agent has, and they're very artificial. Like nobody talks like that. I think it's just like maybe it's the common people talk like parts of that, but nobody talks like that. Like the load bearing, it's important to be honest here, and all the aim dashes and all the, it's not this, it's that, right? So those
Yeah.
patterns, they emerge quite rapidly. So I don't think we have had yet an AI that can fool people about its nature for a prolonged amount of time.
Yeah. No, for sure. That said, it still gives some wow factor for sure. Like I mean, I'm sure like yourself, like I find it amazing how much faster I can move for certain
Oh
things. Like,
yeah. But
and
as I
it's
said, I've been AI pilled for almost a year, let's say at least nine
yeah,
months. I'm very bullish on the technology. You know what? It's, I was talking about like, well, it's already August, so it's probably been like almost a year. I still remember the first thing that I've done that I said, "Oh wow, this is completely for real." And
yeah,
it was in writing a blog. You know what? Let me find, because then I'm going to find the date of the blog. And 2 weeks before that, okay, so it's actually been longer. It's just in my memory. So we published this blog on April the 7th, 2025. So it's just the
okay,
time flies. And in the process of writing that blog, I had my first, oh wow, AI is real moment. So I've actually been longer than that in the AI train. I've been saying 9 months, but just time passes. I have to update
yeah.
my belief system here.
Yeah, no, it's definitely been great for me to like for a few things. There's stuff like I put off on my database, including migrating it to Turso, because I was like, I don't have time to do this right now. I know what, and now it's like I literally every now and then, like on a weekend, I'll just be like, okay, yeah, I'm doing this, porting this, migrate that, boom, 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 and like I've added like end-to-end tests that I help scaffold with AI, but like it's in a place now where like I'm comfortable to move really, really fast, and it's pretty liberating and even trying out stuff. But that said, I was at AI Engineer Miami in I think it was April, and
Yeah,
Dax Reed from Open
yeah.
Code gave I think it was the opening keynote on day one. He's talking about like basically, yeah, it's an amazing time to be alive to just build things or like try out things, but you're creating so many bad things too at the same time because like before there was a process, you know what I mean? That'd be like, okay, the product manager or
But the
owner
same
is
thing
like,
was said about open source. The same thing was said about YouTube. The same thing was said about every one of the technological revolutions. Because what they all do is that they lower the barrier to entry into some domain,
yeah,
and this will. Again, when I've been in open source, Nick, for 25 years, and open source today is the winner, and how
hmm,
again AI might be changing that because a lot of people are afraid of that. I'm not, but open source was far away from being the consensus 25 years ago. You
yeah,
might remember Microsoft calling Linux a cancer and stuff like
yeah.
that. Open
As
source
Steve
was
Ballmer,
viewed
wasn't it?
as, nobody believed in open source. I mean, very few of us believe. I did, and for me, it was I've been doing open source for longer than I've been doing computing because I got in love with the idea of open source first. Easy to do when you're
Yeah,
20. But my professors in university all mock me. They say, "Oh, this is the guy who's going to be coding for free." And people still had this idea of like, how do you make money out of this? Like, this is never going to work. That they, and you know, you would go and download. A lot of us
hmm,
had this idea. Open source is great because there is a piece of software for everything, right? There's just so much open source out there, but most of that open source was completely crap, right?
hmm,
So we were talking about open source with people who were using, like for example, Adobe Photoshop, and we were using GIMP, and say, hey, but this is free and it's up. But GIMP is a piece of
yeah,
crap, still is. By the way, I didn't see it that way because, but the reason I didn't see it that way is that I was not a professional illustrator or photographer
yeah.
or
You're
anything.
like it was
For me, it
is
was
better than Windows Paint for sure.
whatever, man. It just doesn't matter. But like the people who are into it, they say like this is truly really bad. So yeah, there is this mountain of software, but most of it is really bad. So again, yes, you can download software from the internet, but most of it is really bad. And this is being compared to the established vendors, the established software, and the argument that was used at the time against open source is exactly that. I mean, it's all, most of it is useless. There's like 5% that matters. But what I think you don't realize is that, and again, people should realize, because it's not the first time it's happening in our industry, you reduce the cost of creating by 100-fold. 5% is good, 95% is crap, but you're going to have so much of it
Yeah.
that the 5% is now bigger than your entire total before, right? So, and
Yeah.
today there is so much more good open source than there is not open source in general, right? And that's good open source, but the price that you had to pay is that, man, go to GitHub and like there are libraries and things, and people start something and don't follow through. I mean, there's just so much software. And I would venture to say that the proportion of useful open source software is probably still around 5%. But
Yeah.
it grows so much that this 5% becomes bigger than whatever came before. I think AI is going to have a very similar dynamic.
Mm-hmm. Yeah. I'm a big fan of open source too. I think my first contribution was in like 2015, but like I've been working at companies since 2020 that were either completely open source or had like even when I was at Netlify, like the whole company was obviously not open source, but I worked with open source like web framework people. We had open source parts of Netlify. Even where I'm at now, Pomerium, it's open core. So it's like, it's not to say that I would never work for a closed source company, but like I've only seen good things happen in my career since I've been working in open source, to be honest. You know, I've been paid better. I get to work out in the open. I don't know. I enjoy it. It's not for everybody maybe, but and even with AI here, you know, I don't think it's going away. It's just different, right? You know, and there's obviously like a load on maintainers in that respect, but there's, you know, things being put in place to help mitigate some of that. But it's still like, sorry, just closing that. I don't know. I still love working in it. You know, maybe that'll change one day, but for now, I can't picture myself not working in it.
The
So,
thing,
you
the
know.
thing is that open source was a lot more always, and this is one of the things we keep saying. Open source was always, from the get-go, a lot more of a social thing than a technical thing, right?
Mm-hmm.
So you could always fork the Linux kernel, and you could create the Linux, you know, versions of it, and take your own direction. This was always possible, always. So, you know, some of the concerns that people have, which like making, they even call it like the SQLite model and say, hey, the SQLite were visionaries, which again, there's nothing wrong with that in principle, but this maybe we shouldn't make our test suite open source, because then people will just reproduce my software. But the reason people get concerned about it is that along the way, open source kind of became like a top of funnel motion for companies. That's what open source became in a lot of ways. And then, yeah, I mean, you have the concern that somebody will copy your company and all of that. But open source wasn't that initially, and open source wasn't this for us always and never. And if you think again, you can already fork the Linux kernel and create your own version of the Linux kernel. And people don't do this because what people truly are buying into is this community, this polis of people who come down together and make the technical decisions about what the Linux kernel is going to be now and in the future. That is truly what it is, right? So yeah, you can fork it, but you cannot bring in the people, and those people, that social dynamic, that nation, so to speak, at the end of the day is what Linux is like who makes the decisions through which process and what goes in. Everybody can code anything, but this doesn't get accepted to the mainline kernel. This other thing it does. Why is that? So for us, again, open source was always like, this is a way to build let's use a Claudism here, load-bearing. The honest truth is that open source is a way to build load-bearing AM- parts of your infrastructure. And that doesn't change, right? So for us, at the end of the day, what is Turso? Turso is a way to get that stamp to say that this, you know, Cursor the other day played with like, hey, let's get the LLMs to rewrite SQLite. But at the end of the day, again, the testing methodology, the decisions, the roadmap, the future, who gets to call the shots, this is all part of what the open source project is. And, you know, this doesn't change a bit with AI, right? Just
Yeah, for sure. And like the domain knowledge, and like obviously there's things that can pull away at it, but like, you know what I mean? Like you're a database expert, you've been deep in it for years. I am not, you know, there's no way I could just say, yeah, I'm gonna create my own torso. Yeah, yeah. I mean, I could obviously make
Yeah.
something, but like,
I would definitely put code in production for in a language that I know nothing about, in a domain that I know nothing about, for a prototype app that I have on the weekends that is,
yeah, for
low.
sure.
But even that app, I mean, as things start to scale and I start having legal liabilities and I need to understand, and there's security implications. I need an expert to drive this process, and I might not be the expert. I get, somebody else will do this, right?
Yeah, Fuzzy's saying, I would love to pick the other side of this argument.
What is the other side of this argument?
Yeah, I don't know. If, drop a comment there,
Yeah.
Fuzzy, to give a bit more context. But yeah. But that said, it's I I think it's I'm not really believing all the doom and gloom about losing the jobs and stuff. I think technology advances, there's definitely categories of jobs that are going to disappear. It's I feel like it's like the industrial revolution on steroids, kind of, like the horse and buggy people got upset because Ford created cars, but now you're driving cars instead of horse and buggy, like, but there's certain things that will disappear. It's just inevitable because like if it can be automated easily.
Well, the thing is that I'm also in the middle there because I don't know if things necessarily. I don't know if I equate materially more abundant with better necessarily, and I think there are many ways in which our society, for example, is a lot worse post social media, for example.
Yeah,
So not all revolution make things better, and a lot of them. It's a lot easier to make things materially better than to make them better. Also, better, there's some level of subjectivity there. The people who become materially better tend to think that everything is better. But when you look at society
bias,
as a
I guess.
whole, I personally do not like what happened with our society after social media. So I think we live. I think, again, it's not even AI in the mix. I think we live in a very different world before Facebook, so to speak, and I don't think our world is necessarily better. And so I think AI is, the jury is still out. We don't know if it's going to be better or
Mhm.
worse. But you're right in the sense that the doom and gloom is that this is over. Like
Yeah.
it's all done, and we had a good run, and I think this is of course a little bit too much.
Yeah.
But as I said, I don't know if we're going to a better or worse place, and I don't think anybody knows.
Yeah. I guess that's a good place to kind of wrap things up. It's not all doom and gloom and stuff, but it's just interesting times. I guess we could leave it at that. at that. I didn't hear from Fuzzy, so Fuzzy, if you got comments later, just
Let's go
post them
next
on.
on social media.
Yeah, yeah, yeah,
Yeah.
yeah, and we
The place
can.
where I spent an unhealthy amount of time at, and I didn't in 2010. But
Yeah, yeah, yeah. I am sucked into that Twitter bubble pretty often.
yeah.
Cool. Well, listen, Glauber, I'm gonna drop a link again to Turso for folks to check it out. I use it personally. I love it. It's great. Check it out. There's the cloud offering too. And if you have questions, like Glauber was saying, hit them up on X or LinkedIn. I'll grab your LinkedIn as well here. And I know you're always up for debates and healthy conversations about, well, life in general, but also obviously tech
Always,
related stuff. So
always. All right,
yeah, cool.
Nick.
So yeah,
Thanks for
go give
having me.
Glob a follow. Yeah,
Thank
no, thanks,
you.
man. And if you don't mind just staying on for one
I
sec,
will.
and everybody else, thanks for the chat today, and we'll catch you in the next one.